Welcome to The Explainer. Today, we are cutting straight through the hype to bring you the innovation latest, uncovering exactly how the biggest technological breakthroughs of 2026 are practically solving some of the world's most impossible challenges. We are looking at a genuinely pivotal year right now, where emerging tech is finally moving out of the pilot stage and straight into massive, real-world deployment.
So let's dive right in. To really grasp what's happening, we first need to understand a concept called TRIZ. It's a fascinating framework built by analyzing hundreds of thousands of global patents, and it completely flips how we think about progress. It proves that technology evolves by systematically resolving contradictions. Think about it like this. You desperately want more processing power, but you absolutely have to use less energy. Or you need higher crop yields, but you're facing a massive labor shortage. These are called technical contradictions. Solving them isn't about sitting around waiting for a random stroke of genius. It is a highly specific, repeatable science.
And here's our game plan for today. We're going to use this exact contradiction framework to navigate four massive shifts: artificial intelligence, global energy, agriculture, and finally, the friction of global policy.
All right, Section 1, the foundational science of breakthroughs, featuring a core principle you'll see popping up everywhere.
Okay, so a hugely important TRIZ concept is macro to micro evolution. Simply put, the data proves that as technologies mature, they inevitably shrink. They move from the macro level down to the molecular or even atomic scale to get more efficient. We already saw this decades ago, right? Massive, clunky vacuum tubes evolved into microchips packed with billions of integrated circuits. And today, we're watching it happen again in real time, as giant legacy batteries evolve into nanostructured electrodes. Keep this macro to micro shift in the back of your mind, because it is literally reshaping our world as we speak.
Which brings us nicely to Section 2, and our first major contradiction in 2026, the exploding demand for AI versus the physical limits of human input.
The way we're bypassing human bottlenecks right now is through agentic AI. We've officially moved way past chatbots that just answer your questions. We are now dealing with autonomous systems that independently execute really complex multi-step workflows. Take vibe coding, for example. It's so widespread it was named a word of the year in 2025. Developers are just delegating the actual generation and debugging of code entirely to AI agents. In the medical field, cognitive automation is independently managing complex clinical workflows without even waiting for a human to hit go. In the economic payoff, we're seeing software engineering efficiency jump by up to 20%. It's a real game changer.
But as MIT Technology Review highlights in their 2026 breakthroughs, unlocking all this unprecedented AI capability means building massive hyperscale data centers. And that instantly triggers a staggering new contradiction: the unbelievable energy cost required to run the whole shebang. At the exact same time, as AI companions get better at forming intimate relationships with users, we run headfirst into a social contradiction, balancing this new form of digital connection against some very real psychological risks, especially for vulnerable users like minors.
So, how on earth do we power all this? Let's move to Section 3, the massive tension between our exponential need for power and the urgent need to protect the climate.
One incredibly promising answer is nuclear fusion. Guys, this has officially moved from a distant, sci-fi pipe dream into a highly capitalized, emerging commercial industry. Just look at Commonwealth Fusion Systems, or CFS. They recently closed an astounding $3 billion in total funding. Major tech players are so confident in this tech that they're already signing strategic agreements to buy future electricity from these exact fusion plants.
To actually pull this off, the industry is racing to stabilize extreme sun-level plasmas using advanced magnetic confinement. As you can see, we have two competing designs here. The tokamak on the left is a ring-shaped torus, which is currently the most mature design. Then on the right, you have the wildly complex Stellarator, taking a completely different geometric approach. Both are trying to resolve the ultimate contradiction, containing something that is literally hotter than the sun inside a physical structure here on Earth to achieve net energy gain.
Now, while we work on producing clean energy, we still have to clean up the carbon that's already in the air. Returning to our macro to micro framework, carbon capture is going through a massive evolution. The old contradiction was that capturing carbon required so much intense heat and energy that it almost defeated the purpose. Well, in 2026, we are abandoning those heat-wasting batch processing legacy systems. Instead, innovators are using micro-level triggers like highly precise electrical currents or simple moisture removal to cleanly release trapped CO2 without having to boil it out.
Companies like Carbon Capture Inc. are eliminating physical bottlenecks entirely with a continuous loop. Think about it. Instead of turning a massive machine on to capture carbon and then off to bake it out, they literally put the capturing material on a moving conveyor belt. It passes through the open air, absorbs the CO2, glides into a closed chamber for release, and cycles right back around. It never stops. Because of this elegant fix, they can process 3 times more air and slash their operating costs by up to 80%. Absolutely crucial.
We're seeing a very similar leap in agriculture. Let's pivot to Section 4, Farming the Future.
The core contradiction here is stark. We have a soaring global demand for food, but we're facing severe labor shortages, rising costs, and brutal climate volatility. So how are we solving it? By moving ag tech from speculative hype right to real-world ROI. We're replacing generic, harsh synthetic chemicals with highly targeted biologicals made for specific crops. We're deploying purpose-built, autonomous field robots to vineyards and orchards to safely do the work that human crews simply aren't available for anymore. And, maybe most importantly, we're removing the financial bottleneck with things like equipment as a service, so farmers don't have to shoulder all the massive capital risk alone.
All right, final section. We have to confront the reality of deploying all these world-altering technologies, the friction between rapid innovation and our deeply human need for oversight.
We're seeing a massive split screen in global policy right now. The U.S. has decisively pivoted toward deregulation, overturning previous executive orders to prioritize rapid, unhindered innovation over reporting duties. On the flip side, the European Union is actively enforcing their strict AI Act, demanding conformity assessments, mandatory risk categorizations, and rigorous oversight for any high-risk systems. It's essentially a real-time global experiment in how best to govern the future.
And the economic reality of all this rapid deployment is hitting hard. Over 200,000. That's the staggering number of global tech sector layoffs recorded recently, as AI tools fundamentally rewire the labor market. While AI assistants are creating massive productivity jumps for the people using them, they are simultaneously displacing massive amounts of traditional white-collar work. On top of that, our heavy reliance on centralized, hyperscale cloud infrastructure has created a terrifying level of fragility. We've built a digital world that is so interconnected, a single software update error at a major provider can shut down millions of critical global services, from hospitals to airlines, in an absolute instant.
All of this unchecked, centralized power is fueling what experts are calling the 2026 digital trust crisis. We are seeing incredibly sophisticated deepfakes drive massive fraud. I mean, we're talking about a reported $5.3 billion lost just to AI-generated pop star impersonators selling fake concert tickets. There's a tidal wave of copyright lawsuits happening over the data feeding these models, and chatbots are out here acting as unmediated educators for kids. The technological safeguards, like watermarks, they're literally just struggling to keep pace.
Which leaves us with the ultimate contradiction to ponder as we wrap up this explainer. The tools we've built, from agentic AI to continuous carbon capture to fusion energy, are more powerful than anything humanity has ever known. But as these innovations become more and more autonomous, will we step up to enforce the governance required to truly master them, or will we just stand by and allow them to master us? The technology is absolutely ready. The real question is whether we are. Thanks for joining me on this deep dive. Keep questioning the contradictions, and I'll catch you in the next explainer.